Okay, here we're going to do a quick example of the distance formula. So essentially with distance formula, we are going to be finding the distance or the length between two different things. And in this case, we're looking at a coordinate graph. So as a reminder, the distance formula says that the distance of a given line, and it does not have to be a diagonal line, it could be a vertical or horizontal line. The distance of a line is going to be the square root of your x2 minus x1, and I'll explain all this, squared, plus y2 minus y1 squared. Okay, now let's talk about what x2 and x1 are and what y2 and y1 are. Essentially what this is saying right here is we want to know the change in x, so the distance, how far over, how many units over are we going from this point right here to this point over here. Okay, so we want to know, remember this is the x-axis, this is the y-axis, so how many units over are we going from point A, we'll call this point A, to point B. Okay, so really that's just your that should be a triangle, your change in x. Okay, now what it means by x2 and x1, if we have point A, its coordinates could be x2 and y2, and point B we could have the coordinates x1 and y1. So that's where the x2 and x1 come from. Basically, it's looking for the change in x. How far over are we going from point A to point B in the right direction? Okay. Now, essentially, y2 minus y1 is the exact same thing, but with up and down. So we're looking here at your change in y. So how far down, or up in other cases, but in this case we're going down, are we going from A to B? Okay, so that's your change in y. Now if you look carefully at this, at all these random arrows I drew, really we're seeing change in y here. So from this point to this point. And our change in x, we're looking at the change in this x unit to this x unit. Okay, look at that. We have a lovely right triangle. Okay, so another thing I wanted to point out is that distance formula is essentially the same thing as Pythagorean theorem. It's just in disguise. Okay, so we could also say Pythagorean theorem can help us solve this, because Pythagorean theorem is looking at your change in x, right? This distance right here, the length of the change in x, which we could call side A, right? Side A. And the length of side B, your change in y. Okay, so this right here is the same thing as this right here. Okay, so we're going to use this knowledge to figure out the distance between point A and point B. Okay, so we have the points on the graph. We can use the coordinates and plug in the coordinates to this formula right here, and I'll do that just to show the example. So point A, just going to write this out, point A, we have the point that would be 1 on the x and 4 on the y. So we have the point 1, 4. And point B, we're looking at 4 on the x and 2 on the y. So if we wanted to write this out, the distance is going to equal the square root of the change in x. So basically we're finding the difference in our x's. I'm going to use the same color I used before for x. The difference in our x's. So what's 4 minus 1? Right, 4 minus 1. Okay, and then the other part, the change in y. So I have a little plus sign here. There we go. Okay, used blue before. Change in y. Change in y, we're looking at 2 minus 4 or 4 minus 2. It doesn't really matter which direction you're subtracting in, even though you'll get a negative in some cases and a positive in the other. It doesn't matter because we're squaring. We're squaring it. So either way, if it's negative or positive, it'll end up positive because we're squaring it. Okay, so it doesn't matter which order you do it in. So the difference between 4 and 2, difference just means subtract, right? Okay, next step, 4 minus 2, difference there is 2. Okay, and we're gonna do our little add sign. And the distance, or the difference between 4 and 1 is gonna be 3. Now you can also see that by actually just counting on our graph. If you notice the change in x, we're going from 1, there's 1 unit, 2 unit, and 3 units. So you could also, in some cases, just count your units to find your change in x and change in y. So there we have 3 units, and then your change in y, we can count it there as well. That change would be 2. Okay, so we know we're doing right. All right, next thing we're going to do is square those. So 3 times 3 is 9. Plus 2 times 2 is 4. We're almost done. Okay. This looks kind of messy. Okay, we're going to add those two. 9 plus 4 gives us 13. So we're saying that this distance, the distance between point A and point B, is the square root of 13. Now, if we actually want to find that square root of 13, it's going to be approximately 3.61. Okay, so we have the change in y, which is 2. So basically, we're looking at this right triangle. Whoa. We have 2 over here. We have 3 over here. And this distance between points A and points B is 3.61. All right, hope that helps.